So we're recording now. And last class, what we looked at were numbers and the sort of operations you can do on numbers, all of the usual stuff, all the arithmetic operations. And we also saw functions, defining functions and having functions compute things and return things. That was all last class. Now, sort of the other, and we saw there's two kinds of numbers, integers and floating point numbers that behave a little bit differently from each other, and floating point numbers have a few sort of quirks about them that you have to be careful of, that eventually everybody sort of gets bit by one of these floating point quirks. Today, I want to talk about another data type. It's probably the next most common or fundamental data type, and that's strings. So in computer science, strings just mean sequences of characters, and characters usually we think of as meaning like letters, numbers, spaces, these kinds of things. All right. So we're going to look at strings in Python and the stuff you can do with them, and part of that is also looking at how you can take numbers and turn them into strings, and how you can take strings and turn them into numbers in ways that are not completely obvious. Okay. So strings are just sequences of characters. So let's fire up Python and play around a bit. So the way you define a string is you put a sequence of characters inside some quotes. So for example, let's define a string. We'll call it S, and we'll set it equal to this is my first string. Okay. So now I've defined this string called S. If I look at it, there it is. It's this string of characters, and if I print it, there it is. So you notice anything different between inspecting it and printing it? Yes?
You don't see the bottom.
Oh, wonderful. So they've already managed to screw up the projectors in this room. Good. Better? Okay, good. So anybody see the difference between inspecting the string, just typing S and asking, which means the interpreter should show you the value, versus printing the string? Yep.
Well, there are two like, what do you call it? Apostrophes or whatever after the string.
Yeah.
And there are none after if you print it.
Yeah. Okay. So in the Python interpreter, when you inspect something, which can happen if you evaluate an expression, then the result of that expression gets shown to you. Or if you enter a variable name, then the value of that variable gets shown to you. And it tries to show it to you in a way that tells you what it is. And in this case, these apostrophes that you called them, we refer to them actually as single quotes, are telling me that this thing that I'm looking at is a string, and then it shows me its contents. Now, the print function is something that you use, for example, in a user interface to interact with the user or to show the user things. And when I want to print a string, well, I don't want to see the quotes around it. I just really mean to print the contents of the string. And so the print function will do that and just print the contents of the thing. Anyone notice anything else that, for example, the difference between the string that I entered on this line and the string that I was shown on this line? Yeah, so the string that I entered was entered using double quotes. So you use these double quotes to begin the string, to mark the beginning and the end of the string, and everything in between is in the string. But the string that I was shown is printed using single quotes. Okay, so why is that? Well, it turns out that in Python you can enter strings using either single quotes or double quotes. Okay, but they have to match. So if I start a string using a single quote, I should end it using a single quote. If I start it using a double quote, I should end it using a double quote. So if I look at S1, S rather, and S2, those are my two strings. And so that's nice. Python gives you two ways to enter strings. Why two ways? Can anyone think of a good reason why they would give you two different ways to enter a string? Yeah? So what do you mean by apostrophes? Yeah. So I said that a string is a sequence of characters, and, well, to enter a string you put maybe double quotes before and after it, but what if one of the characters that I want in my sequence is actually a quote character? More common, or as common, is when you want to use that single quote character as an apostrophe. So you might want to do something like, say, it's a beautiful day out. So that works. If I delimit my string with double quotes, I start and end it with double quotes, then inside the string I can use single quotes, and there's no confusion that happens there. On the other hand, if I try something like this, then Python gets confused. And the reason it gets confused is, well, it sees me beginning a string with a single quote, and then the contents of the string come, it, and then there's another single quote, and Python thinks, okay, that's the end of this string, which is fine. So far, so good, except next thing comes a letter, which makes no sense to Python anymore, right? That shouldn't have, you shouldn't have a string followed by a letter which looks like a variable name or who knows. Okay? So having two different ways to enter these things is helpful, because if you have a double quoted string and if you want to use single quotes inside your string, you can use double quotes to delimit it, and vice versa. So, for example, you can say, so there's S4. There's a string with double quotes inside of it that's delimited using single quotes. Does this completely solve the problem of confusing what's inside the string with what's used to mark the boundaries of the string? Yeah.
How do you program it if you're trying to quote someone who said something that within the quote has a quote?
Okay. So, no, it doesn't solve the problem, because what if I'm trying to make a string that has both double quotes and single quotes inside of it, as part of the contents of the string? Then having two different ways of doing it doesn't really solve the problem. So there's a few solutions around that that we will look at. I'll show you the first one of those solutions now. So one of the features that we have with strings in Python and most other languages, because this comes up all the time, so this is the kind of problematic thing. I want a single quote and a double quote inside this string. And so if I try and double quote it, I'll run into problems with the double quote. If I try and single quote it, I'll run into problems with the single quote. There's offered this mechanism for what's called escaping things inside the string. And this seems to go back probably 40 or 50 years. The standard way of doing this in many programming languages that deal with strings is to prefix the thing that you're escaping, this special character, with a backslash. So in this case, there's this single quote in here that would be problematic because it looks like it ends the string. And so what I want to do is somehow tell Python, look, there's a single quote here. It's not the end of my string. I want it inside my string. So I need some special way of doing that, and there's a mechanism for it. And that's by putting a backslash in front of it. Python says, okay, what's coming after this backslash is not the end of the string. It's just a quote character that should go inside the string. So don't stop here. Keep reading and parsing the string. Okay. All right. Does that completely solve the problem? Yep.
I have a different question. Do you mean to be recording right now?
I do. Yeah. The red dot up on the top there is what's, oh, of course, something else off the screen. Perfect. Yeah, I am recording. Thank you for that, though. So, does that solve all our problems now? Yeah.
You have a double quote on the outside and then a double quote on the inside. Does the backslash work the same way?
Sure. So let's do that example again, but we'll put the double quotes on the outside. Okay, so this isn't going to work now. What should I do to make it work? Yeah. So I'm trying to delimit my string with these double quotes. So delimit means mark the beginning and end, but there's a double quote inside of it, so I want to just alert Python that that double quote inside isn't a special thing. It's not the delimiter. It's just something that I want to put inside my string. So that does what we would expect. And interestingly, when I inspect this string, S4, we've seen it actually showed up earlier and I glossed over it. When I inspect it, it shows me this string as a single quoted thing, and the single quote inside there has that backslash in front of it. And this is a little bit of a lesson looking forward that actually when I'm in the interpreter and I inspect a variable or some value or an expression, the thing that Python shows me is actually the Python code that I would use to create this thing. So if I wanted to recreate this string, I would just copy and paste that piece of code and notice that it works. It's a string that's delimited with single character, single quotes, and that single quote in the middle is escaped for me. Okay. So usually in the interpreter, what you see when you inspect something is actually valid Python code. It's a valid Python expression. All right. Okay. So so I asked, all right, so now if we want to have quotes, we have these special characters which are quotes that begin and end our string, and if we want quotes inside, we can use a backslash to say that, well, to get them in there, and I asked, does that solve all our problems? So we had this special character, maybe single quote, or this special character double quote, and we solved the problem with putting it inside our string by introducing a special character backslash. Now, what happens if we want a backslash inside our string? Yeah. So, if you want a backslash inside your string, you have to do backslashes. Otherwise, Python, if you only put one backslash, Python just thinks you're telling it, oh, the next character that comes after this backslash is something that I just want inside my string and I don't want it to have any special meaning. And so if you want one backslash inside a string, better to print it, then you should put two backslashes. If you want your string to contain one backslash, then when you make Python code for it, you need to put two backslashes there. Okay. This is all stuff that's well known for people who've been programming for a while, but can sort of trip up beginners. All clear?
What if you want to put a backslash in front of a quotation mark in a string bounded by quotation marks?
Sure. So that would look something like, I would like a backslash. So that's a backslash, and I want to put that in front of a quotation mark. So that's a quotation mark in a string that is delimited by quotation marks. And now it actually becomes, to understand what's in our string, it becomes easier to print it than to look at it, to inspect it, because printing it, then we can see exactly what's in there. Indeed, now in this string there is a backslash and a quotation mark. If I inspect it, of course, I get Python code that recreates the string. So then it looks like there's two backslashes, but there's not. That's just the code you would use if you wanted one backslash. So this finally does the ability for backslash to be a character that escapes things, including backslash, is finally enough to deal with any of the problems that come up here. And this backslash has actually a bunch of different uses. There's actually a bunch of special things that we can use, we can insert into strings using backslashes. So let me show you one of them. This string has a see if that worked. No. Okay. So tab is one of these special characters, and it's kind of hard to enter. If you press tab, then maybe the cursor jumps over and is at spaces or whatever. In a string, if you want a tab inside your string, then you can use a backslash T. Now if I print this thing, then that backslash T really is this tab character that expands into whatever, some number of spaces, or maybe it makes something line up. There's other special characters that you can include this way. A useful one is backslash N. So not that interesting to inspect it, but when you print it, what do you think backslash N is? It's a new line. So a new line character is a character that when you print it actually moves the cursor onto the next line. So that's why when we print this string, it comes out across two different lines with the break happening exactly where I put that backslash N. Here's one you may or may not have seen. Does anybody know what a carriage return is? No, you're all much too young for that. So carriage return goes back to the days of typewriters and original printers that printed one line at a time. So when you're using a typewriter, you type for a while and the letters appear on this line. And typically you hit this big bar, which does two things. It moves the paper up so that you're on the next line, and moves the whole the paper over so that you start again at the beginning of that line. But those are two separate things. Moving the paper up is putting it on a new line. Carriage return is just the act of moving back to the beginning of the line. So there's an old carryover from that, which is there's a special character in the ASCII character set called the carriage return. And in many terminals, not all of them, it actually has the effect of moving the cursor back to the beginning of the line, but not to the next line. So what happened there? I printed a string that says this has a carriage return in it, but all I see is carriage return in it. Yep. Yep. So, so actually, faster than you could see it, probably faster than the monitor could display it, it printed this string has space. The cursor went back to the beginning of the line and then overrode all that stuff with carriage return in it. Doesn't seem like a very useful feature, but it turns out that if you're looking for really cheap ASCII graphics, it's actually a useful thing to be able to do. For example, it lets you implement a counter that counts upwards, for example, without scrolling the text all the way off the screen, right? You can start at 1 and then back up and write 2 and then back up and write 3 and back up and write 4, and you'll see this thing climb up without driving without all of these numbers appearing on your display. I've seen it used to make little animations of things that look like they're spinning using minuses and slashes. So really cheap kind of graphics, sometimes useful in these text-based applications. Okay. Yeah, so the main things you might want to quote are tabs, which show up in things like spreadsheet applications. New lines are really important, and of course the quotes themselves or the backslashes. So I've said there's two ways to enter strings in Python. Actually, there's even more than two ways. There's 3 ways. So let me show you a third way. And Python, so again, sometimes you want to write really long strings, and really long because they have maybe many lines of text in them. And so you should have some nice way of doing that. And Python has these multi-line strings, which start with 3 quotes in a row, and they don't stop until they've seen 3 quotes in a row, and that they don't stop even if you press enter. So So if you have a long string, a multi-line string, maybe like a poem or a joke or something that you want to write as a string, well, a handy way to do it is to use one of these multi-line strings. And multi-line strings come, again, in 2 flavors. You can delimit them with 3 triple quotes at the beginning and end, or you can do 3 single quotes at the beginning and end. Either way works. All right. So, questions so far? Yeah?
How does that last limit? How does that decide how many words put into a line?
I did that. I mean, the reason there's new lines there is because when I was typing it in, I pressed enter at the end of each line. Yeah.
I use common characters that are already used in English. Would it be better if you were just, learning programming language to use some uncommon used characters?
Well, the ASCII alphabet, which is like the original thing we wrote programs in. I mean, I know we have Unicode now, but we don't have Unicode keyboards. and if you look at your keyboard, just about everything on there, it's either used in English or it's used in a programming language. Right? So what do you want to delimit them with? Stars? No, that's multiplication. You want to use parentheses? No, we're already using those. Hashes are used for comments. The ampersand symbol, most programming languages don't use it. It might work, but it still looks weird then for someone to see strings delimited by ampersand symbols, or at least it looks weird to me because I'm used to the other way. And no matter what you use, somebody's going to want to put it in a string and you'll have to escape it. Maybe just pick something that's less common than most things. Yeah. Okay. All right. Okay, so one of the things that we sort of glossed over and that we need to deal with, and especially now that we're dealing with strings. So last class we saw that there's integers, or ints, and floats that behave a little bit differently, but they're both numbers at least. And usually if you do an operation on a number and a couple of integers and it needs to give the result in a float, it just does it for you. But if you want to, you can explicitly convert between the two. So, for example, I showed you that if 4.5 is a float, but if I convert it to an int, then I get 4, the int 4, so it just does truncation. Similarly, 4 is an int, but I can convert it to a float, and then I get 4.0. Okay? Well, now we have this third type of data, which is strings. And so can I convert things to and from strings? And the answer is yes, but not everything works. So for example, if I want to convert something to a string, that almost always works. I just take that thing and I call a function called string, str, and it converts it to a string. Okay? So notice the difference between that and just 4.5. One of those is the string 4.5, and the other one is the floating point number 4.5. Okay. Is that clear? And I can convert ints the same way. There's no issue. 5 is an int, but I can convert it to a string. Now, how about the other way around? So what if I want to make an integer out of a string? Let's see if that works. So this is the string 45, and I'd like to convert it into an integer. And indeed, that seems to work. Right? So a little more slowly. S is the string 45. X is what happens when I convert S into an int. If I look at S, it's a string, and X is an int. Good? So let's try it. Let's try another one of those. Let's take 45.5, and let's say X is the float version of that string. And indeed, that does what we expect. Yep.
So if you define s as some integer and then x equals int of s, that would do anything?
If I define s as some integer, like that, and x equals int of s, then it does what you expect. It takes the int and converts it into an int. So it's an empty operation in some sense. Now, but be careful because this doesn't always work. In particular, strings can have a lot of stuff in them, right? So what's going to happen there? There's a string with A, B, C, D, E, and so on in it. If I try and convert it to an int, I get an error. It's a value error. It's telling me that, and if I read this error message carefully, it tells me that I can't convert this thing into an int because it just doesn't look like an int to me. And similarly, I think if you try and do something like 45.5, it also complains about that. So it doesn't convert it to a float first and then an int. It just says, this isn't an int. I don't know how to convert it. Okay. But if the string, the contents of the string look like an integer, then this will happily convert them into an integer. It's a useful thing. The other way around is easy. Floats you can always convert to strings, and ints you can always convert to strings. Pretty much anything you can convert to a string, because strings can, they can be as long as you want and put anything you want in them. All right. All right, so that's conversions between the data types, some different things you can do with strings. Strings support some operators as well. So for example, let's say S so strings support addition. So I can add two strings together. What do you think that does? So it does what's called concatenation. It takes the first one and adds it after the second one. So that's nice. So if you give me two strings, I can add them together. Now, here's a question for you just a quick question. When I add two numbers together, like 4 plus 5, is that the same? Do I get the same result if I add 5 plus 4? If I add two strings together, S plus T, do I get the same result if I add T plus S? No. So this plus operator doesn't quite behave the same way as it does for numbers. It's not, you can't change the what's on the left and what's on the right matters. So it's something that you may have to keep in mind. All right, so I can add two strings. What about adding a string and a number? Do you think that works? No. It tells me that I'm trying to add two things, and it gives me a type error. It says that thing that you're trying to add to this string, it must be a string, not an int. How do we fix that? Yeah. I could put quotes around 45, but I wasn't trying to add S plus 45, I was trying to add S plus the variable X. So putting quotes around it, is that going to do what I want? Well, I don't want to do that because maybe X is the result of some calculation, right? I mean, this is a simple example here, but maybe the way that I got X is I converted some pounds to kilograms, and now I'm trying to show you what that looks like. Yeah?
S plus string X.
Yeah. So S plus quotes around X doesn't work because then it just adds the string X. But X is a thing that can be converted to a string, and then it works fine. So all that's doing then is adding two strings together, the string representation of 45. Yeah? Does it matter? Oh, that's because I have some practice with this, and when I made my string, I put in an extra space at the end of it. You see it there. I've made that mistake and had to correct it a million times in the past. Okay? Good? All right, so you can add strings together. Here's something else you can print strings. So sort of the opposite of printing a string is somehow getting a string from someone. So printing it is showing a string to the user. And what if you want to get the string from a user? Well, Python has a function for that. It's called input. And input takes one argument, which is a string. And that argument is, it's what it displays. It's called the prompt. It's what you display to the user when you're asking for this input. So you might say something like, enter your name. And then Python prints, enter your name. And then you see the cursor is just sitting there waiting for me to type my name. I type it. I press enter. And it's done. And where did that get stored? Well, it's right there in the value s. So if you need input from the user, you can get it with this, unsurprisingly, input function. Okay. But let's be careful here. Course. So what's the value of x right now? The value of x is the string 29. It's not the integer 29. So if you prompt someone using input and you're asking for a number, what you get is a string. You have to convert it to a number yourself. And of course, this is always annoying because now if you're going to do something like write a program that tries to convert that thing to an int, well, fine, it works, but it leaves an opportunity for the user to break your program now, because the user can use your program like this, and then you convert their input to an int, and your program crashes. So user input is always bad, never to be trusted, and we'll learn how to cope with bad user input a little later in the course, but for now, in particular for assignment 1, if the thing asks you to write a function that prompts the user for something, you can assume the user gives you what it is you're asking for. They're not trying to break your program, but actually I don't think it matters in assignment 1 because we don't take user input and convert it to numbers. Okay, so let's do a really dumb example. Let's make a cash register. So it'll do something like ask for a number A. It'll ask for a number B. And it will print A plus B. Okay, number A is 45, number B is 5, and you see, we just made the mistake. Is that what we expected? Why not? Because A and B are strings, right? This input function gives us strings. So before we add them together, we should convert them to numbers. And, well, if I say number, then I'm not being specific about being an integer, and if I'm talking about a cash register, maybe the number might have dollars and cents, so there might be a floating point number. So maybe we'll convert these things to floats. So rather than A just being the string that comes back from the input, it's what we get after we convert that thing to a float. $45 and 5, and we get 50. Okay. So I don't like that there's been no questions really so far. Anybody want clarification on anything yet? So a lack of questions usually means some kind of divide in which some number of people think this is obvious and trivial and understand everything, and some other people are completely lost and don't understand anything. I'm happy to answer questions from either type of those people. Yes? Yep.
So you're running the scripts through, you said GA, right?
Yep.
I'm having trouble understanding how to run it through PowerShell.
Okay. Okay. So I'm almost not using the shell at all. I'm almost entirely in the Python interpreter. The only time I drop back into the shell is to load up Python again because I've changed the file. So if you're struggling with that aspect of things, the most likely issue is you have an editor that's working on a file, and then you have a shell open, and the file that the editor is working on is in a different directory than the shell is sitting in.
Okay. I mean, yeah, I figured that out a couple days ago, but actually it's in the same directory. That's my issue. I guess should we be working mainly in Python or PowerShell?
PowerShell is just the thing. It's just the shell on Windows that you use. I use Bash, and the Mac OS people also end up using Bash. So you almost don't interact with it at all, except to change to the right directory, and then keep starting up Python, and then you quit Python, and then you start Python again. So the shell, you almost need to know. You need to know very little, except maybe how to change the directory. And if you can't figure out how to change the directory, then just save the file in whatever directory the shell is in. But yeah, so there's almost no shell. It's not even shell programming. There's almost no use of the command line here except for these starting Python and exiting it again. Yeah. Yes? Is float only used for, float is used to convert whatever its argument is into a float. So if I give it an argument that's an int, it'll do the natural thing. It'll convert it to a float, which just means it doesn't change except now it has a floating point representation. If I give it a string, then it'll try and interpret that string as a number and convert it to a float, and it might fail, and then it'll give you an error. Right? So it happily accepts things like 45, strings like 45 or 45.0 or any of these things, but yeah. So float basically makes floating point numbers. Okay. Other questions? Yep.
So if you change float to the ints, and then enter our inputs as float, like you said, or just convert?
If I change float to where? In this function?
Yeah.
Okay. So if I change float in that function to something like this, let me get it and reload it. So 45 and 5. looks like it almost does the same thing. There's a slight difference in the output. The result now is an int instead of a float, so it gets printed as 50 instead of 50.0. But it's a little bit less general now, because if I try and enter something like 45.5 here, then it's going to crash. Again, this is why user input is problematic for things, because users tend to either on purpose or by accident enter bad inputs that you need to check carefully. Here we're not worried about that yet, but if I was making something that is taking numbers from the user, then it's more likely to work if I take floats. Then it'll work for things like 45.5. Okay. All right. Okay, that's good. So we've seen a very simple way to take numbers and convert them to strings, but sometimes we want to do fancier things. So, for example, if I'm working with a cash register, which is supposed to mean maybe it's a Canadian cash register, then, you know, what's a typical, or bank machine or any of these things, what's the typical view you see when someone shows you an amount of money? Like $45. How is that normally written? Usually, it also tells you the number of cents, right? So it's usually written as something like 45.00, or, you know, if it's $45.25, then it's 45.25. So it's kind of like a float, but the amount of precision is, at least the amount of precision that you can see, is fixed in some way at two decimal points. So there's a lot of time that we want to take numbers and turn them into strings or print them, but in a more carefully formatted way. Like, for example, even this one, sometimes it prints 50 and sometimes it prints 50.0, and it just happens to be whether or not its argument is a float or an integer. And maybe I would like to do this in a more careful way. And maybe I would like to do it so that it's in a way that it always prints two decimal places. Okay, so there's a whole mechanism for formatting all kinds of things as strings, and I'd like to just briefly introduce you to it and point you to where you can look for more details, because it's I won't say it's complicated, but it's very flexible and there's a lot of things you can do. So I won't bother to explain it all. But the main idea is you make a string looks like that. Okay, it has a little space in it, a special thing in it that has an open curly brace and a closed curly brace. And, okay, so nothing special there so far, that's fine. But strings have a function called format that replaces those curly braces with whatever you want. So, for example, if I say s.format 45, it takes that string s and it looks for those curly braces and it'll replace them with 45. In fact, the string 45. Which is already a little bit nicer than taking s and adding 45, because if we did that, we would have had to first convert 45 into a string. So this is already a nicer way to do it. And you can do several of these. Okay. So you put a few of these pairs of curly braces in your string, and then call format with the same number of arguments as there are pairs of curly braces, and those things get nicely replaced. Okay, questions? So far this is fairly simple, but it's already a little bit nicer than constantly having to add strings together and convert things to strings. Is this clear? Okay. Now, the way I've done it here, there's nothing special about these curly braces. I can replace them with anything. So in particular, I could replace them with other strings. So now that first one gets replaced with XX, and the second one gets replaced with YY. And nothing special about ints either. Can use floats there, and it'll do that too. Okay, so it'll do this sort of natural thing. In fact, what it's doing is it's taking whatever that argument is and calling the string function on it and sticking that where those curly braces used to be. But you can do a bit more than that. Inside these curly braces, there's a whole language of things you can do to specify what this thing should look like. And so the way to do that is you start with a colon, and then you can pick there's a whole bunch of things you can do, but one of the main things you might do is to specify, maybe you're trying to print numbers or integers or different kinds of numbers. So for example, let's do something maybe a bit boring, but only useful for contrast. So here what I've done is I put this colon D, and D stands for decimal integer. So it's just going to print it like a decimal integer. So it's going to convert it to an int first. All right. Let's try something maybe. Well, let's see if we can break this thing. So if I've told you to format it like a decimal integer, but I give you 45.5, which is not an integer, I get an error. So that's good. I tried to give it something that it wasn't supposed to be able to do, and it failed, as it probably should have. So what other specifiers can we put here? Well, let's try a different one, x. Anybody know what happened there? If you don't know what x does, maybe you know what b does. No? Yeah?
Binary?
Yeah. So this b format specifier says that I want you to print an integer, but I don't want you to print it in the decimal representation that we're used to. So decimal here doesn't mean the decimal point. Decimal means base 10. B means binary. I want you to print the binary representation of that integer. Now, if you've never worked with binary numbers before, don't worry about it. It's just this is how you would write the value 45, or the value that we call 45, if you only had zeros and ones to work with, rather than the digits 0 through 9. Okay? And, well, if B is binary, then do you know what this X is? Yep. Yeah. So this is, X is this hexadecimal notation where not only do you have the numbers, they're the digits 0 through 9, but you have 0 through 9, A, B, C, D, E, F. So you have 16 different digits to work with. One of those digits is D, which happens to stand for 14, I think. Yeah. Okay, so don't worry too much about that. But there's just sort of different ways of printing integers here. All right, that's good. Now, another one of these format specifiers is colon is with F, and that prints it as a float. And kind of weirdly, it prints it as a float with a lot of, it really shows you this is a float. There's a lot of things that come after the decimal point here. That's not exactly what we want. So we can make this even fancier. And if we're doing our cash register, I can tell it I want this thing printed as a float, and I want exactly 2 digits of precision after the decimal point. So that's the kind of thing that I would want to put in a cash register. So let's just try and make that look a little bit more like a cash register. So A plus B is the thing that I want to print, and I want to print that with a $sign in front of it, and I want to print it as a float with 2 digits of precision. Like that. Okay. So I have a string, I call its format function, and that's going to go and replace these curly braces here and the stuff inside it with exactly the thing that I specified. Let's give that a test. I forgot the colon. And there indeed it prints it the way that I like it. So I don't want to spend, I could spend several classes talking about all of these things. So I just want to point you, if you just look up string format, or Python string format, you'll get the whole specification of this language and all of the different things that it supports. And that format specification, that stuff inside the curly braces, I showed you just a couple of really simple things where you can do floating point numbers and say how many digits of precision, but you can specify the width of the string, you can specify whether it should be the width of the thing that's formatted, you can specify whether it's aligned to the right, whether it's aligned to the left. If it's an integer, you can specify different kinds of bases that it could be displayed in. There's a whole pile of things. These are just ways of doing integers here. Here's a pile of ways of doing floating point numbers, but really the most useful thing on this page is not to read that specification or the thing, but it's to look at some examples until you find one that does something close to what you're trying to do. So know that there's a lot of ways to convert things into strings using this formatting stuff. All right. Okay. So back to looking at strings. So a string is a sequence of characters. And sometimes I don't want the whole sequence. Maybe I only want a part of it. So, for example, maybe I only want the first character in the sequence. Well, I can ask for that. So this sequence, Really, it's the sequence HERE space IS space MY space STRI space and so on. And so each element in this sequence has an index, and those things start at 0. So the 0th thing in the string is the letter H. The 1th thing in the string is the letter E. The 2th thing in the string is the letter R. And I'm being really specific here and saying 0th, 1th, and 2th rather than 1st, 2nd, and 3rd, because 1st, 2nd, and 3rd is confusing the way we normally use it, because 1st, for sure, to me, looks like the letter H in this string, but it's the 0th element in the string. Okay? So there it is. At position 1 is the letter E, position 2 is R, position 3 is E, and what's at position 4? A space. Okay? So I can access the characters of this string individually. Okay? Maybe not a surprise if you programmed in another language. But I can do more than that. I can access parts of the string. I can ask for everything, all of this string, starting from position 5 and going up to, but not including, position 10. So that gives is my. Okay. So those are things at positions 5, 6, 7, 8, and 9. But not what's at position 10, because at position 10 is the space that comes after my. So that's called a slice of a string. You slice a piece out of it. And you specify the starting index of the slice and the index that comes, after the end of the slice. So one more than the last piece you want. Okay? So remember that these kinds of off by one errors show up all the time. Because of this indexing by 0. If you find this confusing, well, another way to do it, and even programmatically, is if you know the length of the slice you want, then you can use that. So, for example, if I want to start at position 5 and I want 7 characters of the string, then I'm going up to position 5 plus 7. Okay. Up to, but not including 5 plus 7. Okay. All right. So I can pull out little bits of strings using these slices. That's great. So you saw if I want the first character in the string, I do s at 0. Here's something that may surprise, let me show a couple of other things first. When I take a slice like this, I can leave out where it should end. I say, I want the string starting at position 5, going up to the end of the string. And indeed, that's what I get. Or I can leave out the beginning and say, I want the string starting from the beginning, so I leave out that first bit, and up to but not including position 10. That's what I get there. So I can get prefixes or suffixes or even full substrings. And here's something that may surprise you. If I ask for the string at position -1, what do you think that is? An error? It's n. Why is it n? Yeah, so if I specify a negative index, it actually interprets that as starting at the back of the string and working backwards, with the final character of the string being the one at position -1. Okay? And so then -2 is that second last character in the string. -3 is that third last character in the string. So notice there's an asymmetry here. If I want the first character in the string, I ask for s at 0. If I want the last character in the string, I ask for s at -1. Why wouldn't it be s at -0? Yes? Yeah, because -0 is the same thing as 0, so it doesn't make sense. So you got to do something reasonable, but the negative integers count backwards. All right. Okay, a little bit more about slices that you can do. Let's start at maybe position 5 in the string and go up to position 15. You can even specify a third thing in here, which is called a stride, which says, okay, I want positions 5 up to but not including 15, but I only want every second character, for example. So I get that I, then I skip the S and I get the space, and then I skip the M and I get the Y, and I skip the space and I get the S, and then I skip the T and I get the R, and then I skip the I. And you can do that with any stride you want. 3, for example, gives you something shorter. And I can leave out any of these things. So, for example, if I just want every third character of my string, starting with the first one, the 0th character, then that's what it looks like. If I want every second character, that's what it looks like. What if I want every 1th character? Yep, it's just the whole string. What if I want every -1th character? Yep. So it does some clever interpretation when you leave out these bounds, the start and end, and it just does what the only thing that could make sense. It's saying, well, leaving out the beginning and end means the whole string, and the stride is -1, meaning, well, he's asking me to count backwards. So I'll start at the end and count backwards and output the letters in that order, and that's the equivalent of reversing the string. So there's a super common recipe in Python to reverse something is to do this. You take a slice where you don't specify the beginning of the end, and the stride is -1. Yep?
Does it just keep looping? Like if you put like -45, it's just going to work back through it until it gets to it?
No. So if I put -45, it gives me n because it's negative, so it's starting with the final letter, and then it subtracts, goes 45 letters forward in the string, but there's nothing there anymore. So it's over at that point. So it gives you one letter, and then there's nothing else. So you may or may not have noticed it. When I went from like 5 to 15 by 3s, somehow the last letter got lost because it sort of jumped over it, and it didn't print it, and after that was too far. So it does sort of the only reasonable thing you can expect it to do. I guess the other thing you might expect it to do is to throw an error or crash or something, but this seems reasonable. Saying I want every 45th character starting with the last one. Okay, give me the last one, and then there's no more. Okay? All right. Is everything clear? Yeah.
Could you ask me to repeat the slicing of the 5, 15, and 8?
Okay. So it's helpful to have S as a reference. S from 5 to up to, but not including 15, is that thing. And if I use a stride of 2, I start with the I skip the S, I take the space, I skip the M, I take the Y, I skip the space, and so on. Just every second character. All right. Okay, so last thing then is a few, so something that I recommend you do frequently is when you want to know something more about Python, just Google it. So for example, I want to know what else strings can do. Maybe, so W3 schools. A good place is docs.python.org. They'll give you a whole pile of built-in functions for strings. And so let's just examine a few of them. So let's say S is, and I think I can say S.upper converts the string to uppercase, or rather it gives me a new string, which is that one converted to uppercase. I can ask for lower. I can ask questions about the string. So does S end with M, or MO, let's say? Does the string Pat Morin end with MO? No. Does it end with IN? Yes. Okay. So you can ask questions like that about the string. There's also a begins with. I think I can do something like this. You can ask it to capitalize the words in a string. That's pretty English specific and not perfect. I would say even that it's even wrong on this example, but it's kind of a handy hack if you want to capitalize the first letter of each word. And another sort of helpful formatter, although you kind of already know where to look for another place to do this, is the center method, which takes the string and it takes an argument, which is how long you want, and it'll give me a 50-character string where my original string is, in the middle as close as possible. It might be off by 1 if things are even, or depending on whether things are even or odd, but it kind of centers it. So nice for pretty printing. But if you look at the string format specifiers, you'll realize there's even another way to do that using these format strings. And one that I hesitate to show you because it's often misused, but can be useful, is the find method. So I can ask to find something in a string. So in the string War and Peace, I can ask to find X, and I get back a result that's -1. What does that mean? In this case, it seems to mean that it's not found. So it's not anywhere in the string. But if I ask to find A, it gives me 1. And indeed, S2 at position 1 is A, right? That's the That's the A in war. And if I ask to find and, it tells me that's at 4. And indeed, that's where the word and first appears in the string. So find can be used to find the first occurrence of something in a string. Yep. What if you want to find all of the occurrences? Yeah, so I can do the first occurrence, or the 0th occurrence, is at position 1. The next one is at position 4. So it seems that you can find a second argument which asks for, you can specify which occurrence you want. And once you learn how to loop, then you can go through that until there are no more occurrences. Not the best way to, not the most efficient way to do it, but it's possible. And there is a third A, right? Piece is, I don't know. Well, let's see what the find documentation is. Oh no, I was wrong about that. So find returns the lowest index where the substring is found. And it takes two optional arguments, which are where to start looking and where to stop looking. Okay, so how would you use that then to do what you're asking? So first thing I might do is say find A. So that starts at position 1. Now if I want the second A, this is why it was working, then skip over position 0 and 1 and then start looking at position 2. And that'll give me the location of the second A. And now if I want the third A, which is at position 4, I'll skip over positions 0 through 4 and start looking at starting at position 5, and that tells me it's at position 10. And as usual in Python, there's lots of different ways to do this. So equivalently, I could say s2.findA. That's how I find the first one. And then next time, do the same thing. Only look at the string, which is S2, starting from position 2 to the end. But that will be confusing to me because it will tell me, well, it starts at position 2, but that's position 2 in this modified shorter substring. Now I have to add 2 because I've skipped over 2 letters. So that's a little more confusing. That's why find offers you this convenient way of doing it. All right, so that's the place to leave it for today. Please do start working on your assignments. Ask lots of questions on the forum. And if you know the answers to questions people are asking, please answer them on the forums.
Hey, sorry, just a quick question. I saw
Just a second,
Oh,
let
sorry.
me